Finally, it it builds a community of entrepreneurs, business people, and industrialists and investors that work together. So on the way, you have to overcome some myths and face reality. Just to mention a couple, people believe that royalties are a significant source of revenue for the university. This is not the case most times. In most cases, licensing revenue is relatively small. And expect quick return of technology transfer investment. And you shouldn't expect product royalties before 8 to 10 years. And the other myth is the companies are eager to accept new technologies from universities. This is maybe true, partially true, but most companies want quick time to market, and this is not always possible with academic research and new ideas. So the T3 office, the technology transfers, besides doing the most important work and mission of creating the IP, because without the IP you have nothing. Besides this, when they have established spin-off companies, they have different new programs to support these. And one is the Dymotech company, is a holding company for the startup enterprises. It is established to enable projects at the R&D stage to reach their commercial potential, and they form alliances, they foster growth, and are involved in every faculty of the Technion. Another mechanism is the Technion Incubator, which is a private seed pre-seed investor. They invest in technology-based startups, and they owned by private money and the Technion. And they are licensed by the government as an incubator, which means that they get governmental funds as well. And what they seek for high risk, high reward ideas, technologies, and they finance it and bring it to preliminary maturity. There are additional funds at the Technion. I won't get into this. And what are the criteria for success? And it's very obvious. The criteria has increased number of investigators and departments that disclosing their technologies per year, increased number of established companies per year, increased number of cooperation and licensing to global companies, increased recognition, and etc. It's increased revenues for licenses. These are parameters, and the Technion is measuring this every year, and we are advancing every year in the nominal numbers. So this is the goal, and if you see this as your goal, you do everything to achieve those goals. Just the headlines of successful examples. I won't get into it. I have too many examples here. Just go over it, you will understand how deep is the success there. In every aspect of the technological field, in medicine, in biomedicine, cell therapy, communication networks, everything. An example of which I told you before, this is the Azilect, the anti-Parkinson's disease drug developed by Teva Pharmaceutical and the two professors from the medicine, from my faculty. Some of you who don't know probably heard about this disease. It is a progressive condition that involves gradual loss of nerve cell function, affecting 1% of the population over 65, and the Technion gets 4% royalties of net sales. This is a lot of money. So in average, we have 1 to 7 new companies annually established as a spin-offs of technologies of the Technion. Now I want to give you just one tiny example of fascinating technology. This is called MR-guided focused ultrasound. Focused ultrasound guided by magnetic resonance imaging. What is focused ultrasound? It is the effect that is similar to the magnifying glass that you may use in the yard to concentrate sun rays, sun energy to a single point. It is done by ultrasound, by transducers, the ultrasound transducer. The system is composed of two elements: high-intensity focused ultrasound element, which I'll show you where it is embedded in the system, a transducer that creates ultrasound beam, and MRI system, a regular MRI system. MRI, the biggest advantage of MRI is its ability to measure temperature very accurately. No other imaging modality can do this. This is an example of the transducer that creates the ultrasound beam that is focused. This is a glass full of gel, transparent gel. And now it is firing. And see what happens in the gel. It is heated, and if it was a tissue, it would ablate the tissue by excessive heat. The transducer are many. You can have a transducer in the bed of the MRI that will be aimed at an organ inside. You can have a strappable transducer. You can have a transanal transducer for prostate treatment, and you can have this helmet, which I'm going to talk about. Actually, what is important to understand that focused ultrasound generates heat and ablates tissue only at the focal point, because all the way the energy is not enough to create heat and to ablate tissue. Only at the focal point, and you can control the focus. You can make it small, change its sizes and different parameters of the focal point. And then during the action of sonication, you can measure temperature. You can measure it by color, by graph, and change your parameter accordingly if it's too hot, if it's too cold. And this is only to show you the correlation between histology and what the MRI shows. And you see that the temperature measurement here at this point inside the focus is very high, and just less than 1 millimeter aside, which is outside the focus, the temperature is not rising. This is an example of treatment aimed to relieve pain from bone metastasis. The system moves, fires, hits the periosteum, which covers the bone, and destroy nerve endings, and this is how it relieves pain. Transcranial ablation is very difficult. We used to think that ultrasound cannot penetrate the skull. It can, but the problem was to focus it. And the skull is different, the width of the skull is different in many places. So what happened, there was a need to create an algorithm based on different thickness of the skull in different places that will enable us to correct these aberrations, and instead of getting a diffuse focus like this, getting a very accurate focus while transmitting the ultrasound through the skull. So this is the system, this is the MRI, the bed, the helmet with all the ultrasound elements, more than 1,000. And this is just a cartoon to show you how it works. The patient is positioned with the helmet. It goes inside the system. Cold water around the skull to prevent damage to the meninges, to what's covering the brain. And the system fires and creates a focus where you want it to ablate tissue. This is again, the same, this is the system, and advantages are obvious. I don't have to elaborate on this. It's non-invasive, totally non-invasive, which is a dream, fantasy, actually. Essential tremor is just one example, is a disease that affects elderly people, and it causes tremor that interferes with normal life. Those people that suffer from this disease cannot write, cannot put on shirts, cannot do anything with their hands.